Hi, today we are going to discuss about queue and array manipulation method. So before that, we will discuss how to realize the multi-dimensional array and how to access a particular portion of the array and how we can able to assign values to the particular portion of the array. So this is the AA is the array name. It is a multi-dimensional array, 4 dimensions there. So first we need to consider this part. Okay, at the right hand side. First we need to consider this one 3 is to 0. There are 4 locations. Okay. So 4 row we have to draw. This is AA of 3 and this is AA of 2, this is AA of 1 and this is AA of 0. Then next you need to consider this one. In each row there are 2 columns. One is 1, this is 1 column and this is 0th column. Okay, this one how we can represent AA 3 of 1. Okay. So this is realized this is mentioned by AA 2 of 1. Okay. In the same way, this will be mentioned with AA 3 of 0. Then after we complete the right hand side, go to the left hand side and next preference you have to give to this part. Okay. Here there are 4 segments. Okay, this one, this is second, and this is third, and this is fourth. Okay. There are 4 segments. Okay, this is represented. Let's take this segment. Okay, AA of 3. This row in that AA of 3 of 1. That representing this one. In that of 0. Okay, that is this segment. And inside that next preference is this one. Inside that we have 2 subfields. Okay. So that is this one and this one. 2 subfields. So I want to access a bit from this. So inside that it can be able to store a bit. Okay. So I want to access this value A of 3 of 1 of 0 of 0. A of 3 of this is 1 of 0 of 0. It represents this location. Okay. I want to assign value for this whole segment. Okay, I can represent as A of 3 of 1 equal to, it has 8, can able to store 8 bits, right? So 8 tick B, then 8 binary values we can do. Okay. Now moving to Q. Okay, Q is as like a dynamic array. Okay, but here we have more options or more methods compared to dynamic array. Here you can able to access or delete a particular values in between the queue. Okay. Then as like dynamic array, a queue can grow on string based on the values we are giving to the queue and we are taking to the queue during the runtime. And queues is a variable size. Okay, this is the way you have to represent the queue. Okay, dollar symbol in this square bracket. Okay, this is the data type which the queue can hold. Okay. The data type you have to mention here, and this is the queue name. In this square bracket we need to mention dollar, that indicates it is a queue. Okay. So the data will be stored in the sequence of locations. Okay, when you mention the queue name itself, automatically it will store in sequence of addresses. Okay. Then it is a collection of homogeneous elements. Okay. If you mention the data type, it can able to store that type of data. Then queue supports adding and removing elements from anywhere. That we will see in the next slide. Then we generally classified queue as a bounded and unbounded. Bounded in the sense, this is example for bounded. The size of the queue is bounded to a particular size. Here $:255. The size of the queue is 256. Then these are unbounded. You can put a number of values in the unbounded queues. Here, this is the way you need to initialize values to queue. The Q1 we declared here. Okay, it can capable to store 2 bits. Okay, it is bit 1:0. So inside queue you can able to put 2 bits. So the maximum value I can able to put 3. Okay, these are the values I am putting in the queue. So if I mention like this, 0th value will be loaded to Q1 of 0, 1 is loaded to Q1 of 1, and 2 is loaded to Q1 of 2, and 3 is loaded to Q1 of 3. And it can support any data type, right? So here Q4 is declared as a string Q4. So I can able to put strings. So string you should use double quote. So within this bracket, red, green, and blue I am putting inside the queue. Then these are the methods associated with the queue size that returns the number of elements which is present in the queue. And insert. So this keyword is used to insert the value wherever you are mentioning here. So this is a index position IP. See, representing index position, you need to mention the position where I want to add this value. Then delete. Delete is a method to delete a particular value, okay, where you are mentioning which value you are mentioning to this IP index position, that value will be deleted. Then we have push front, push back. These two methods are used to insert the values. Whatever the value you are giving inside the bracket, that value will be inserted to the queue. Okay, if you use push front, it will push on top of the queue. When you use a push back, it will push the bottom, okay, at the backside of the queue. Then pop method. Okay, pop method is used to remove the value from the queue. It will remove the value. So if you give pop front, it will take from the top. If you give pop back, it will take from the bottom. And here you should not use variables here. Okay, while pop up, this method will return the popped value. So for that we want to use a variable here. For example, I have a variable. Okay, a equal to pop print. So it will pop print the value from the queue and it is assigned to a. Okay, we will discuss those things in the example. Okay, in this example, I created two queues. One is Q1 and Q2. Okay, first one is can capable to hold 32 bits. Okay. Second one is to hold string. And here inside the initial block, I am assigning values for queues. Q1 0, 1, 2, 3 I am putting, and for Q2 I am putting red, blue, green. Here with the help of $display, I am printing the size of the Q1. Dot size is used to give the size of the Q1. Q1 size is, I am putting 4 values, right? So the size of the Q is 4. Then with the help of for each, I am displaying the Q values along with the index. Q1 of %0 D equal to %0 D. So if I mention like this, first this %0 D is for I, that is for index, and this %0 D is for the value, nothing but Q1 of I. The value present in that ith location that will be displayed here. So These are the values I put here. I am getting those values. Okay. Then q2 dot size. q2 I put 3 strings, so the size is 3. Here I am displaying those things using %0s and displaying the strings here. And then here, with the help of insert method, I am going to insert orange in the first location. Okay, this is the existing one. Okay, so I want to insert orange in this location with the help of insert. After inserting, I am just displaying the size and displaying the elements in the Q2. The size becoming 4 after inserting orange to the first location. So orange is inserted in the first location. If you insert to a particular location, the automatically the blue is present at first location. It will move to the second location. Okay. See here. It is the advantage of Q. Then, with the help of delete, I can able to delete a particular location value. So in dynamic array, we don't have this option. If you give dot delete, automatically all the elements will be deleted. Here you have the facility to delete the particular value by mentioning the index. Delete of 3. So which is present in 3, green. So I can able to delete this position. Okay. After that, the size become 3. Then I am printing the content of the Q2. Okay. Now green is not there. Then in next example, we are going to see about these methods, push and pop methods. So here also I created a queue, Q1, table to store 32-bit. I assigned values for Q1, okay, 0, 1, 2, 3, and then this is %0p. Percentage P is used to display the content of queue or array in packed form. So in the early example, I displayed the value along with the index. Here, with the help of %P, I am displaying the values in packed form. So you will get the output like this. Okay. Actually, this is the unpacked array, as like unpacked array. Okay. This one I can able to print in packed form with the help of %P. So it will be displayed like this. Then the size, I put 4 values, right? So the size is 4. Then with the help of push front, okay, you have to mention queue name dot push front. What you want to push at the front, that you need to mention inside the bracket. 8 I want to add in the front or top of the queue. So after displaying this, see here 8 is inserted in the front. The size also increased with the help of dot size. I'm getting size as per earlier it is 4. After inserting 8, it is becoming 5. Then with the help of push back, I am inserting 9 at the back of the queue. You see here 9 is inserted back of the queue. Now the size becomes 6. Then with the help of pop print, I am accessing or removing the first element which is present in the queue. First element is 8 is there. Okay. This one I popped up. After that, you have these elements inside the queue. Okay, the size will be reduced. So 8 is popped out. After that, I am popped back. So this is the existing one. From this, I am pop back element from queue. So this is present at the last, right? So this is removed. 9 is removed. and this is the final queue elements we have inside the Q1. So here you need to assign a variable, okay, for holding the elements which is popped from the queue. Okay. You should not mention within this bracket. Okay. This method will pop up the value from Q1 and it is assigned to this variable. Then one more example we will see for Q. Okay, in this example, I created a queue of int type and I declare a variable index as int and temp as int. Then I assigned some values for queue. This one I put inside the queue. After that, with the help of for each, I am displaying queue along with the index. See here, I am printing those values. Okay, after that, the size is 5. With the help of dot size, I am printing the size of the queue. Here, what I am doing is, with the help of queue random range, okay, I assign some random value for the index, which I declared as int, right? So this index position of queue, I am taking the value and I am assign that to temp var, and I am going to display those things. This is the existing queue. With the help of random range, I am assigning some value for index, and with the help of index variable, I am accessing the particular value of the queue. Let's see here. Repeat 2 times. First time, $random range. This is the system task that will give some value within this range. Okay. First time you are getting 3. 3 is assigned for the index, and Q of 3. Q of 3 means this one. Q of 3 we have 0. So this is assigned to temp var. Here I am displaying the index and temp value. So index 3 value we are getting 0. And the next iteration, index is 0. In 0th position, Q of 0 we have 7. Q of 0 we have 7. After that I am displaying the Q dot size. Here see here 5. Still it is 5. So when you access the elements randomly, or when you access the elements from the queue, the help of this access method, the value is assigned to some variable. Okay, it is not removed from the queue. That is the thing I want to convey you. When you use pop, okay, the value is removed from the queue, but when you access this method, the elements will be assigned, this value is assigned to some other variable, but it is not removed from the queue. If you use dot delete, you can able to remove that, and if you use pop, you can able to remove that. Okay, but with this method, you cannot able to remove the elements from the queue. Okay, next we are going to discuss about array manipulation methods. So these methods are used to search, order, and reduce the array. These are the methods used for search, and this method used for order, and these methods are used for reduce this array. So this is the general syntax array name. You can use this method here, array method, and argument x we can use, or item is the default keyword representing as an argument with expression. So let's see this example. Okay. Here qi and ia. Okay. So this is a q and this is a associative array star. So that is indicates it's an associative array. This dollar indicates a q. So both can, it is a int data type. So both can be able to store a int type of data. So here let's assume associative array consists of some values. Okay, 10 values are there. In the 10 values, I want to know which are all the values greater than 5, and those values I want to put inside this queue. So this I can do with the help of the array method find. So a dot find of x with x greater than 5. So this array name dot find here argument x with expression x greater than 5. So what it will do, it will check for each element whether it is greater than 5 or not. There are 10 elements. Let's assume that from 1 to 10 there are values. Okay, so it will check that. So 6, 7, 8, 9, 10, those values are greater than 5. Those values are assigned to this queue. Here this expression with expression class is optional for this certain methods. You can also use those methods. Without this with expression, you can mention these methods. And one more example. Okay, here this array, static array, and this queue or string data type. Okay. Now sa dot unique s. Okay, this variable argument you can use any variable here. Okay. Yes with s to lower. That means inside the static array we already put some strings, okay, as a element. So with the help of unique, it will check for the unique strings. Okay. That should be a lowercase. Those strings with unique characters, that means unique word with lowercase is assigned to this SQ. Then, okay, we will discuss these methods with the example. Okay, here I create an static array of size 9. So I can put 9 values. I assigned 9 values for the static array. So the location start from 0. This is 4 is stored in array of 0. This is stored in array of 1. Likewise, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. This one is stored in array of 8. Then here I create a queue to hold the value which I am going to access from this array. So it should be an int. Okay. Here all the values are int data type. So to capture or hold that value, I need the same data type. So I created a queue res with int data type. And this one I created this one. I will explain that. Now here what I am doing, array dot find x with x greater than 3. So in this array I am going to find x should be greater than 3. So here what are the elements greater than 3? 4, 7, 5, 7, 6. Okay, there are 5 elements are greater than 3. So those 5 elements are sent to queue. So here I just mentioned res. Res is a queue. So it will store in its sequence of locations. See here, after putting this, I am displaying the queue with the help of %p in factor form. So figures 4, 7, 5, 7, 6 are stored in the queue. Then array dot find index. Here I am asking for find index. So this is the another way. This is the one way to represent the expression. Here I am giving the argument with x is greater than 3. So another way you can use this item keyword. So convention directly find index with item that represent the elements which is present in the array equal to 3. So here which is equal to 3, this one. Okay, so I am asking for find index. What is the index of these 3? This is 0, 1, 2, 3, 4, 5, 6, 7. So 7 is the index. So it is sent to this res queue. So that one we are getting here. Okay. Then next one, find first. So find first, it means first we check the condition. Item less than 5 and item greater than or equal to 3. So here this is less than 5 and it is greater than or equal to 3. This is satisfied and this satisfied and this this one satisfied. Okay. Here I am asking for the element that should satisfy this condition and find first. So which one satisfied first? So here 4 satisfied, right? This is the first element that satisfied this condition. So this 4 is sent to this queue and we are printing that one. Then the next method, find first index. So in this early method that sends the element, first element that satisfied the condition. Here I want to send the index, okay, which satisfied this condition. Element, it will check for the elements, okay, and it send the index value to the queue. So x greater than 5. So this, okay, this is greater than 5. So this is the first element which satisfied this one. So what is the index? 1. Okay. So that is sending to queue res that we are getting here with the help of the display. Okay. Then the same way, array dot find last. So let's check which satisfied this one. Item less than or equal to 7. Okay, we will search from last because it is asking for the last element. Okay. So okay, 6, right? It is less than 7. It is greater than 3. Okay. So this 6 is passed to the queue. So that you are getting here. Okay. Then the same way, if I want to get the index, okay, and the expression is given x is less than 3, so here it is array find last index. So x less than 3, so this satisfied, right? So this is the last element which satisfied this condition. Then I want to pass the index. So index is 8, right? From 0 to 8. So that index is passed here and we are getting that here. This one. Then min, max, unique index, all these methods are there. So I already told with expression that the class is optional here. If you want, you can use. Otherwise, directly you can mention array.min. So it will give the minimum value to here in this array, which is minimum value 1. With that we are so here just displaying here. I'm displaying q value here. So minimum value is 1, that is sent to q, that we are displaying. The same way max. What is the maximum value here? 7. So that is stored in the queue. Then unique. Unique in the sense it will check for each value. So here 7 is there, again 7 is there, so it is considered as a duplicate 1, and it will take only 1 7, and this one will be considered, and this one will assume as a duplicate 1, and it is not sent to the queue. So see here 4 4 7 2 5, and that 7 is then neglected, and again 1 6 3, and this one is not considered. Okay, that is the use of unique. Then next one is unique index. Okay, before that I created one associative array, right? The index is a type of int and the value is also a type of int. AA is the associative array. So here I am going to take the index, okay, from the array, find index with item greater than 3. So which are all the values greater than 3? This one, this one, this one, this one, and this. Okay, I am taking these indexes. Okay, I'm going to take this index and I am putting in the queue. Okay. In this index the values are greater than 3. Okay. So I put those index and I put in this queue that I am displaying here. Then with the help of for each, I am going to put the value which is present in the index to the associative array. In this way, array, this is res of idx. Okay. Res of idx is nothing but this one, 0. The first location 0 is there. Okay, this res idx is nothing but 0. So array of 0 equal to associative array of 0, which is present in array of 0, 4. That 4 value, okay, I am putting to associative array 0th location. I am putting value 4. So this way. Okay. So here I use for it. So for all the index, I am accessing the value, okay, which is present in array, and those value I am putting in the associative array. Okay. So it is the form of lookup table, right? So it's when you print the associative array, it is displaying along with the index. 4 is stored in 0th location, 7 is stored in first location, 5 is stored in third location, 7 is stored in fourth location, 6 is stored in sixth location. So now with the help of unique index, I am taking the values and put in the queue and I am displaying. So when you give unique index, it will consider the values which is present in the associative array. Okay. Now see 4, 7, 5, 7. 7 is repeating, right? So it will not consider this part. It is considered as a duplicate one, and these are all the unique one, and the is index are sent to the QRES. So 0, 1, 3, 6. That's we are taking here. Then next ordering methods. Reverse. If you give array dot reverse, automatically it will print in reverse order. So in this example, string is a dynamic array. You are assigning some string values to the dynamic array, and with the help of dot reverse, it will print in the reverse order. Student comes first, apple, and then teacher. Then this is the structure. Already we discussed about struct data type. So struct, inside that we can able to give any data type. Okay. So red, green, blue, or a type of byte, and video is the structure name. Here I created 512 locations of the video. Okay, or we can say 512 instance. Okay. So here you can assign values for red, green, byte, like video dot red equal to some value, like that. That is video of 1 dot red equal to some value. Then video of 2 dot red equal to some value, like that. You can able to assign values for these variables. Okay. So I want to sort this whole structure. Okay. Elements, that is there are 512 videos are there, right? 512 instance or 512 locations are there. So I want to sort them corresponding to the red value. With respect to red value, I want to sort them. So how I can do that means video dot start sort video dot sort this method with item dot red. So with respect to red, I want to arrange the whole thing in a ascending order. If I want to arrange in a descending order, I want to use R sort. And shuffle is to shuffle the elements inside the array. Then this for this method we will see an example in media playground. Then reduce, so some product. So if you give sum, return the sum of all the elements. See this example byte. So it is a static dynamic array. I assign some 4 values. Okay, b array name dot sum. It will return the output of for it will perform sum for all these elements. 1 plus 2 plus 3 plus 4. It will return that value. So y I declared as int. So this y can hold the sum of these elements. The same way dot product we use, it will do multiplication and it will return the value. The same way you can use AND, OR, and XOR. So here it will behave as a bitwise, so that we will see in the example. So this example is for order. Okay. So I created a static array and I put these 9 values inside that static array, and with the help of reverse, so this is the actual position. So if I give reverse, it will display it in reverse order. Then dot sort, it will arrange in the ascending order. See here, and it is reversed, then it is arranged in ascending order from low to high, and if you use R short, it will do in the reverse order. It is in descending order. Then here I used a dot shuffle, array dot shuffle. So the element location will be shuffle. So here I'm going to run this puff item with the help of for loop. So each time I'm displaying, so elements locations are differing, right? So this is the use of shuffle method. The last thing is reduce methods. So this is the static array, and I assign some 4 values for each locations. I am displaying those values here. Okay, with the help of %b, I am displaying in binary format. It is a int data type, right? So it is displaying 32-bit. Here dot sum, what it will do? It will add these elements and it will return the value. It's 10. And product will multiply these values and it will return the value. Then dot and, so it will perform bitwise AND operation between these elements. Let's check here. So AND, right? So here any one of the element is 0, you will get 0. So here you will get 0, here you will get 0. So I am getting 0 as the output. When you perform OR, when one of the element is 1, you will get 1. Here 1, here 1, and you will get 1 here. So triple 1 is the answer. And then XOR. So for XOR. 1 XOR with 0, 1, 1 XOR with 1, 0. So here we are getting 0. And for this location, 1, 0, and 0. Here we are getting 1, 0, 1 XOR 1. So we are getting this one. Okay. So these are the methods which will be helpful to reduce the arrays. Okay. So remaining we will see later. Okay. Bye.